So in this equation, we have to find out a matrix A such that the given matrix equation holds. So we begin by figuring out what should be the order of A. So the first matrix has an order of, let's call it X. The matrix X has the order of 3 by 2. It has 3 rows and 2 columns. That one is multiplied to matrix A. We have to find out the order, and this is yielding a matrix Y which has the order of 3 by 2. So the best way to find out the order of this matrix is to consider a 2 by 2 matrix. So we see that the column of the first matrix must be equal to the row of the second matrix. Then the matrix multiplication is possible, and in order to get a 3 by 2 matrix, now we already have a row 3 for the first matrix, and to have column 2 for 2 columns for the second for matrix Y, we need to have 2 rows in matrix A. So that means matrix A should be of the order 2 cross 2. So let us assume A to be equals to A, B, C, and D. Now what we're going to do, so we are going to multiply this matrix A to our matrix X. So this implies 2, negative 1, 1, 0, negative 3, 4, and we are going to multiply it to the 2 by 2 matrix A, B, C, and D. And this is going to yield us the matrix Y, which is negative 1, negative 8, 1, negative 2, and 9 and 22. So let's begin our multiplication. So this should give us 2A minus of C. So we have taken the first row and multiplied it to the first column. Then to find out the second element, we consider the first row and then multiply it to the second column. So this will give us 2B minus of D. Then we continue. We take the second row for the third element. We take the second row and multiply to the first column. So that should give us 1 times A is A and 0 times C is C. So we don't have to write. Then to find out the fourth element, we take the second row and multiply to the second column. So that should give us B. 1 times B is B and 0 times D is 0. So B plus 0 is B simply. Then for the third element, we get negative 3A plus 4C. And for the final element, we'll have negative 3B plus 4D. And this is equals to our matrix X, our matrix Y, which is negative 1, negative 8, 1, negative 2, 9, and 22. Since they are equal matrices and both are of the same order, we can equate the corresponding elements. So the first equation will give us 2A minus of C is equals to negative 1. Then we get 2B minus of D is equals to negative 8. Then A is equals to 1 and B is equals to negative 2. So we don't have to rewrite the other equations. This full equation will help us to find out all the values. Now we already have A equals to 1 and B equals to negative 2. So let us plug in the value of A equals to 1 into the first equation. So that should give us 2 times 1 minus of C equals to negative 1. We have 2 times 1 is 2. So we have C equals to negative 1 minus negative 2. So negative C is equals to negative 3. Multiplying both sides by negative 1, that gives us C is equals to 3. Then we take B equals to negative 2 and plug it into a second equation. So we have 2 times negative 2 minus of D is equals to negative 8. So this is negative 4 minus of D is equals to negative 8. Negative D is equals to negative 8 plus 4. So negative D is equals to negative 2. And multiplying both sides by negative 1, we get D is equals to 2. So we have all the 4 values. So that means our matrix A is simply 1, negative 2, 3, and 2. So this is our required matrix. In this question, we are provided with 3 matrices, A, B, and C. All of them are 2 by 2 matrices. Then we are provided with an equation CD minus AB is equals to the 0 matrix. So using this equation and the 3 matrix values, we have to determine the value of our matrix D. So let us assume, so let D be a 2 by 2 matrix, this is only going to make the multiplication possible. So let D be a 2 by 2 matrix with elements. We'll say given by A, B, C, and D. And what we're going to do is we're going to consider the equation CD minus AB is equals to the 0 matrix. We take CD equals to AB plus 0 matrix. So this is simply going to give us AB. Now what we do, we plug in the value of all the matrices. So C is 2, 5, 3, 8. Then our assumed matrix D has the values A, B, C, and D. And this is equals to A, which is 2, negative 1, 3, 4, times B, 5, 2, 7, 4. Now we're going to multiply it. So 2 by 2 matrix multiplied to a 2 by 2 matrix. So we have the first equation will be, the first element will be 2a plus 5c. So we have taken the first row and multiplied to the first column. For the second element, we'll get 2b plus 5d. So we have taken the first row and multiplied to the second column. Then we have 3a plus 8c. So we have taken the second row and multiplied to the first column of the second matrix. Similarly, we consider the second row of the first matrix and then multiply to the second row of the second column of the second matrix. So that should give us 3b plus 8d. And this is equals to the multiplication of a and b. So that should give us 2 plus 5 is 10. Minus 1 plus 7 is negative 7. Then we have 2 times 2 is 4. Minus of negative 4. 3 times 5 is 15. 15 plus 7 times 4 is 28. 3 times 2 is 6 plus 4 times 4 is 16. So we're going to simplify these values and then we're going to equate them. So this is 2a plus 5c. Well, let me do one thing and let me copy this value. And then we rewrite 10 minus 7 is 3, 4 minus 4 is 0. This is going to be 43, and 16 plus 6 is 22. So let's equate them. Let's equate the values. So we have 2a plus 5c is equals to 3, and 3a plus 8c is equals to 43. And the other two sets will be 2b plus 5d is equals to 0, and 3b plus 8d is equals to 22. So we'll solve the first two equations and that should give us the value of a and c. So what we're going to do here, so let's rename our equation. This is our equation number 1, this is equation number 2, this is equation number 3, and we have equation number 4. So what I'm going to do here, I'm going to consider equation number 2 and then multiply throughout by 2. So we take equation number 2 and multiply throughout by 2. So that should give us 6a plus 16c equals to 86. And then we take equation number 1 and multiply throughout by 3. So that would give us 6a plus 15c equals to 9. So what we're going to do, we're going to subtract the two equations. That's what gives 6a and 6a would cancel each other. 16c minus 15c is simply going to be c, and 86 minus 9 is going to be 77. So that is the value of c. Now, what we're going to do, we're going to substitute the value of c in equation number 1. That will give us the value of a. So we have 2 of a plus 5 times 77 equals to 3. We have 2's of a. 5 times 77 is 385. That is equals to 3. So we have 2's of a equals to 3 minus 385. So 2 of a is equals to negative 382. So we divide both sides by 2. So that gives us minus 191. So that is the value of a. So we have the value of a and we have the value of c. Now we go to the remaining two equations and then find out the value of b and c. So what we're going to do, we're going to consider equation number 4 first and then multiply it throughout by 2. So that should give us 2 times 3 is 6, so we have 6b, 2 times 8 is 16, 16b, and 2 times 22 is 44. Then we take equation number 3 and multiply it by 3. So 3 times 2b will give us 6b plus 3 times 5d is going to give us 15d. So I made a mistake here. So this is 16d. So this is equals to 0. So 6b and 6b is going to cancel out each other. 16d minus 15d is going to give us d, and the value for d is 44. Now let's take this value d of d equals to 44 and plug it into our third equation. So we have 2b plus 5 times 44, which is equals to 30. Then we have 2b is equals to negative 5 times 44. And we divide both sides by 2, then that should give us b. So this is 5 times 44 divided by 2. So b is equals to negative 5. So 2 times 22 is 44. So we have 5 times 22. So b is negative 110. So now that we have all the values, so our matrix D is going to be matrix D. So let's write down all the values here. So we have A is negative 191, B is negative 110, C is equals to 77, and D is equals to 44. So now that we all have all the values, so our matrix D will be equals to negative 191, negative 110, 77 and 44. So that is our required matrix. So in this question, we are given a 3 by 3 matrix A. Using this information, we need to first find out the value of a squared minus 5a plus 4i. And in part 2, we have to find out a squared minus 3a plus 2i. And then using information provided in 1, we need to find out the matrix X such that the matrix equation holds. So let's begin by finding out the value of a squared. So a squared is simply going to be, we take the matrix A, 2, 0, 1, 2, 1, 3, 1, negative 1, 0, and then multiply it to itself. 2, 0, 1, 2, 1, 3, 1, negative 1, 0. So this is going to be equals to, so we take the first row and the first multiply to the first column. So we'll get 2 times 2 is 4, plus 0, plus 1. So this is going to be 4 plus 1. So let me quickly write down all the values. So we'll have, next one is 0 plus 0, negative 1, 2 plus 0 plus 0, and we have 4 plus 2 plus 3, 0 plus 1 minus 3, 2 plus 3 plus 0, or 2 minus of 2 plus 0, 2 minus 2 plus 0, 0, negative 1 plus 0, and we have 1, negative 3 plus 0. So we further simplify it, and that should give us the value of a squared, and that is going to be simply 5, negative 1, 2, 9, negative 2, 5, 0, negative 1, negative 2. So we have the value for e squared. Now what we do, we're going to plug it into our first equation, which is the first expression, number 1, which is a squared minus 5a plus 4i. So that is going to be equals to 5, negative 1, 2, 9, negative 2, 5, 0, negative 1, negative 2, minus 5 times our matrix A, which is 2, 0, 1, 2, 1, 3, 1, negative 1, 0, plus 4 times I. Now I is an identity matrix, so since all the matrices are of the order 3 by 3, we have to consider a matrix, which identity matrix, which is also of the same order. So we'll have 1, 0, 0, 0, 1, 0, and 0, 0, 1. Then we're going to simplify this. So let's do that step by step. So this is equals to 5, negative 1, 2, 9, negative 2, 5, 0, negative 1, negative 2, minus 5 times 2 is 10, so we have 10, 0, 5, 10, 5, 15, 5, negative 5, 0, plus 4, 0, 0, 0, 4, 0, and 0, 0, 4, which is equals to, finally we do the manipulation, so we have 5 minus 10 plus 4, so let me write it down, 5 minus 10 plus 4, then negative 1, negative 0 plus 0, 2 minus 5 plus 0, 9 minus 10 plus 0, 5 minus 5 plus 4, 5 minus 15 plus 0, 0 minus 5 plus 0, then negative 1, negative times negative 5 will be positive 5, plus 0, and finally we have negative 2, negative 0, and positive 4. Oh, good. So let's simplify it, and that will give us the value negative 1, negative 1, negative 3, negative 1, positive 4, wait, I think I made a mistake here. This is the mistake here, so this is negative 2, so this is negative 2, negative 5 plus 4, so this is negative 7 plus 4, which should have given us negative 3. So this is not 4, but this is negative 3. Then 5 minus 15 is negative 10, negative 10 plus 0 is simply negative 10. Well, we have negative 5, 5 minus 1 is positive 4, and 4 minus 2 is positive 2. So this is the value for e squared minus of 5a plus 4i. So this is our value for 1. Now what we have to do is we have to find out the value of a squared minus 3a plus 2i. So let's do that. So we need to find out a squared minus 3a plus 2i. So same thing. So what we're going to do, we're going to write down the value of a squared. So what we're going to do is I'm going to pick this up and do some changes here. Everything remains the same. So the manipulation, so this is, instead of 5, this is going to be 3, and instead of 4, this is going to be 2. All that remains the same. And then we do the manipulation. So this will be 5. So let me copy this. Times negative. So 3 times 2 is 6. 0. 3 times 1 is 3. 6. 3. 9. 3. Negative 3. 0. Plus 2. 0. 0. 0. 2. 0. And 0. 0. 2. Then we add and subtract the 3 matrices. So this should give us 5 minus 6 plus 2. Now we have negative 1, 0, 0. No need to write it. 2 minus 3 plus 0. 9 minus 6 plus 0. Then we have negative 2, negative 3 plus 2. 5 minus 9 plus 0, 0, negative 3. And this will be positive because negative times wait, right, 0 minus 3, so this is simply minus 3 plus 0. Okay, then we have negative 1, and so minus 3 is positive 3, and then 0. Then we have minus 2, 0, and plus 2. So that should give us 5 plus 2 is 7, 7 minus 6 is 1. So 1, negative 1, negative 1, positive 3, negative 3, negative 4, negative 3, 2, and 0. So this is the value for a squared minus 3a plus 2i. So we have the value for 2 as well. Now, using the first one, let me rewrite it. So this is the value that we got. Let me place it here. And then what we have to do, we have to find out the value of a squared minus of 5a plus 4i plus x equals to 0. We have to find out the value of matrix x. So we have to find out the value of matrix x. So what we can do, we can rewrite this equation as a squared minus, so let me rewrite the equation first, plus 4i plus x equals to the 0 matrix. So what we can do, we can write x is equals to O minus a squared minus of 5i plus 4i. Now, adding a matrix to a 0 matrix leaves the matrix itself. So we'll be simply left with a squared minus 5a plus 4i. 4i, so which is equals to negative times the matrix. So let me copy it. So this is the matrix. So we simply have to multiply each entries by negative 1. So we get x equals to 1, 1, 3, 1, 3, 10, and 5, negative 4, negative 2. So that's it. So that is the value of x, matrix x. So this is done. Let's go to the next one. So here in this question, we are given two matrices, A and B, both are of the same order, which is 2 by 2. And then we are given a matrix equation, A plus B squared is equals to A squared plus B squared. Now, using this information, we need to find out the value of A and B. So what we do, so let's add A and B together. So A plus B is simply going to be, so we add the corresponding elements. So the first element will be a plus 1, negative 1 plus 1 will be 0, 2 plus b, we can write it as b plus 2, and then negative 1 is going to give us negative 2. So this is our matrix a plus b. Now what we're going to do, we're going to find out the value of a plus b squared. So what we have to do, we'll take the matrix a plus b and then multiply it to itself. So we have the matrix A, and then we're going to multiply it to each other. So this is the product. So that should give us, the first one will be a plus 1 whole squared plus 0. Then in the second element will be, we'll take the first row a plus 1 and 0 and multiply it to the second column. So this is simply going to be 0. Then we have the third entry, which is b plus 2 times a plus 1 negative 2 times b plus 2. So I'm going to shift this to the side. Okay. Then b plus 2 times 0 is 0, and negative 2 times negative 2 is 4. So this is our a plus b squared. So let's simplify it. So it should give us a squared plus twice of a plus 1. Now I suggest you to do the manipulation here, and what you should get here is ab plus 2a minus b minus 2. So check out this expansion, and then you should get this result. What will have 0 and 4. So this is our a plus b squared. So that's done. Now what we have to do, we'll have to find out the value of a squared and b squared. So we have a is equals to 1, negative 1, 2, negative 1. So let's try to find out the value of a squared. So this will be simply the matrix A. And then we multiply it to itself. So this should give us 1, negative 2. Then we have negative 1 plus 1, 2, negative 2, negative 2, positive 1. So that gives us a squared is equals to negative 1, 0, 0, negative 1. So this is the value of a squared. Okay, let me mark it. So this is a squared. We have here a plus b squared. We'll be all using these values a little well later from now on, so because we have to find out the value of b squared as well. So we have b squared is b is equals to, switch it down, what's b? a1b minus 1. Simply a1b negative 1. So we have to find out the value of b squared. So b squared will be a1b negative 1 times a1b negative 1. Let's find it out. So this is simply going to be a times a is a squared plus 1 times b is b. A times 1 is a, 1 times negative 1 is negative 1, b times a is ab, negative 1 times b is negative b, then we have b times 1 is b, and negative 1 times negative 1 is positive 1, so we'll have b plus 1. Okay, that's it. So we have both the value for a squared and b squared. So this is b squared. Let's mark it. So this is our b squared. So that's it. So now let's write down all the values together. So this is our a squared closer. this is a plus b whole squared. Then we had found out a squared, so a squared was this is a squared, and then we found out b squared, so we have all the values that we need. There's a few more things that we need to do. This is our b squared. Now we have to find out a squared plus b squared. So a squared plus b squared is simply the matrix a squared, and this one is added to b squared. Let's keep it a little closer. So this should give us a squared plus b minus of 1, a minus 1, ab minus b, and simply b. So we have the value of a squared plus b squared. Now, in our original question, it was given that a plus b whole squared is equals to a squared plus b squared. So since we have found out the value of a plus b whole squared, and this is the value, so let's take this matrix, write it downstairs. So this is a plus b whole squared, and this value is equals to a squared plus b squared, which we found out just now. So this is a squared plus b squared, and we equate the two matrices. So let me change the parentheses. So this is done. Now what we're going to do, we're going to equate the two equations. So this simply gives us b is equals to, okay, so we take the entry 4 and equate it to b, so that gives us b is equals to 4, and we equate a minus 1 to 0, so that is a minus 1 is equals to 0, so that gives us a equals to 1. So there we go, we have the value of a and b.